Let's talk about HeapSort. Before we dive into the algorithm, you need to understand what is a heap. You can consider the heap as a complete binary tree. So what is a binary tree? The binary tree means the node has only two trials, the left trial and the right trial. The complete binary tree, that means we are building the tree from left to right. Let's say we are given the array like this. First, we are going to build the heap. So we insert 5 as the root. And we are building the tree from left to right. That means first we always insert left trial, so 2 and 3. Again, we are building from left to right, so we are inserting 1 as the left trial of 2. Let me give you a counter example. If we have the tree like this, that means this is the non-complete tree since we are missing 2 nodes here. So if we convert the array into heap, the indexes will be like this. At 5 we have indexes 0. This 1 and this 2 and this 3. So by definition, we can define the left trial is equal to I times 2 plus 1. And the right trial is I times 2 plus 2. Now you know what is a heap. Let's bring in more concepts. Let's talk about the max and min heap. The max heap means the parent node is always greater than the trial. So from the root, the number 5 is always greater than the left trial and the right trial. And the number 2 is always greater than 1, which is the left trial. The min heap means the parent is always smaller than the trials. So the 1 is always smaller than the left and the right. 2 is always smaller than 5. In order to achieve HeapSort, let's implement a function called heaplify. And let's consider to build a max heap. The heaplify function means that every subtree is a max heap. For example, if we are calling the heaplify function on here, on this subtree, they are not a max heap. So we need to substitute the root. We need to bring 9 to the root and bring 0 as the right trial. There is another thing you need to consider in the heaplify. You always need to select the maximum between the left trial and the right trial. In this case, you bring the right trial which the maximum, because you cannot bring the 4 into the node. Otherwise, it will become a non-max heap. And here's the Python code for the heaplify function. Inside the function, we have 2 parameters. The I means the current index for the subtree. The n currently means the length of the nums. But this can change later as we are building the HeapSort. First, let's define the largest variable as the I index. And the left trial means the I times 2 plus 1. The right trial means I times 2 plus 2. Consider right now we are on the index I here. And we're looking for the subtree here. So the largest index currently is 1. The left trial is 3. And the right trial is 4. We have 2 if statements to ensure the left trial and right trial is always less than the end index. Let's first compare the largest index with the left trial index. Now we know that 0 is smaller than 4, so we update the largest index to be 3. Now let's compare the nums at index 3 with the nums at right trial. We know that 4 is less than 9, so we update the largest to be index 4. By implementing these 2 if statements, you can see we always select the maximum between the right and the left trial. In the final if statement, we check if the largest index is equal to the ith index. If they are not, that means this is a non-max heap. So we need to substitute from index I to the index largest. And we are calling the recursive function heaplify again, because we are not sure how deep is the tree goes. So we need to ensure that every trial or every subtree they are max heap. Now you know how to implement the heaplify function. Let's convert this given array into the max heap. Again, this tree is currently just a binary tree. And the way you can imagine this array into this graph is that by selecting each node from left to right, that's how you build a tree. Right now we are about to call in the heaplify function. Right now you have 2 options. You either can traverse the array from left to right, or you can traverse the array from right to left. I believe many people, even myself, were thinking at first we're doing from left to right, because heaplify function can make sure every subtree it's a max heap. However, this approach left to right is not gonna work. Think about in this example here, that if we call the heaplify on the root, this will be substituted by 7, and this will be substituted by 4. But the actual rule is 9 here. So the maximum in this tree, 9, it was supposed to go as the root. So the correct way to build a max heap is by traversing from right to left, from the last element to the beginnings. That way, we are traversing from the leaf nodes to the non-leaf nodes. So you can ensure that every subtree we build, they are max heap, this is max heap, and this is max heap. You can even try to improve this procedure, because implement the heaplify function on the leaf nodes, it doesn't make sense because the leaf nodes doesn't have the trials, right? So if we implement the heaplify function starting from the non-leaf nodes, from right to left, that way we can save some time complexity. So the non-leaf nodes can be shown as the length of the array divided by 2 and then minus 1. From the last approach, we know how to convert the array into the max heap. Now let's dive into implementing the heap sort. The heap sort is based on the max heap, because we know that the root of the max heap is always the largest. So we need to bring it to the last element of the array. So we substitute minus 1 with 9, and then we bring minus 1 to be the first. And we are calling the heaplify on the first element because now we know that the whole array is a non-max heap. So after calling the heaplify function, it will restructure the whole array to be a max heap. So this is a max heap, and we'll continue to swap the first as the root of the max heap with the last. One thing to keep that in mind is that the last element is no longer the last element of the array, because we already finished the sorting of the number 9 here, so the last element is actually the sub-array. And that's the reason we introduced the variable end in the parameter of the function. So at first, n means the length of the array. But on the second call, that means the length of the array minus 1. Because as we keep the sorting, the length of the sub-array will be shrink. And here's the whole Python code. The first for loop is for building the max heap. The second for loop is for the heap sort. In terms of the time complexity, the first for loop we have on because we are looking for every node. The second for loop it has on as well. For each node, the heaplify function has O log n time complexity, because it depends on the height of the tree, which is log n. The heaplify function can go deeper and deeper depends on how tall is the tree. It is the same as building the heap sort, so the total complexity is n times log n. If you like this channel, please click like and subscribe. Thank you.